It's HYLN video time, and we're going to see where the term unlock comes from and what its purpose is. In this video, which I'll play some clips of, you'll hear Mr. Healy use the word unlock.
Unlock, I mentioned Stirling engines, they're not new, they've been around for over a century. Well, the unlock is we're using additive manufacturing to make the key components of the generator.
The unique thing with each one of these parts is there are geometries within these that really just offer major unlocks to get us that efficiency, to help improve the size of the system that you couldn't get if you made this through conventional manufacturing. And this creates another unlock, which is very limited waste.
Yeah, so it's not atypical that we have 99% reuse on our powder, and we'll continue to reuse it over and over again until it's essentially eliminated. Again, only use the material you need and not anything more.
A lot of the unlocking appears to be centering around making these parts. Here's an article that also used the term unlock. However, there are measures that can unlock existing system capacity. If I'm a grid operator, an electric grid operator, what are the things I can do between now and 2030 to unlock incremental capacity on my system with things like grid enhancing technologies and storage? So there are grid operators that are looking to unlock additional system capacity. So where does all this unlocking stuff come from? And it turns out that the origins of it appear to come from this World Economic Forum, which Thomas, he recently visited in September of 2024. And this is entitled Unlocking Technology for the Global Goals, and this was published on January of 2020. And inside this document, the first sentence reads, "It is crucial to find new ways of leading, working, and innovating to unlock and scale the promise of the fourth industrial revolution for people and the planet." The fourth industrial revolution, the founder and executive chairman of the World Economic Forum wrote a book in, I think, 2015, 2016, that time frame, called The Fourth Industrial Revolution. And in this book, one of the drivers, and drivers are countless organizations, have produced list ranking the various technologies that will drive the fourth industrial revolution. And one of these in the physical realm is 3D printing. Also called additive manufacturing. 3D printing consists of creating a physical object by printing layer upon layer from a 3D drawing or model. The technology is being used in a broad range of applications, from large wind turbines to small medical implants. For the moment, it is primarily limited to applications in the automotive, aerospace, and medical industries. Unlike mass-produced manufactured goods, 3D printed products can be easily customized. As current size, cost, and speed constraints are progressively overcome, 3D printing will become more pervasive to include integrated electronic components such as circuit boards and even human cells and organs. So one of the unlocks to the technology is one of these drivers, and that's 3D printing. And GE Aerospace, their business unit, is one of the keys for those drivers. It's a type of key, it's not the key. And HYLN is using that. Let's play another clip And in here, he talks, this person, Michael, he talks about a fuel nozzle.
So we were working on fuel nozzles, which is basically how you inject fuel to a jet engine. And as we took that journey, we went from jet engines to say, hey, where else in the world can additive be a benefit? And one recurring theme was always just thermal systems or heat exchanger design, which ultimately led to the Carnot generator and where we started working on this project.
In the Fourth Industrial Revolution, which was written by the founder of the World Economic Forum, here it cites an example of 3D printing for manufactured has been recently covered by Fortune. General Electric's LEAP jet engine is not only one of the company's best sellers, it's going to incorporate a fuel nozzle. Well, this is crazy. There's a fuel nozzle from General Electric that is appearing in this book published by the World Economic Forum. It could be some sort of strange coincidence. I'm not sure. Let's continue. It's going to incorporate a fuel nozzle produced entirely through additive manufacturing. The process, popularly known as 3D printing, involves building up layers of material according to precise digital plans. GE is currently completing testing of the new LEAP engines, but the benefit of additive manufactured parts has already been proven on other models. So it cites this fuel nozzle by General Electric, HYLN. Occasionally they'll talk about a fuel nozzle, and it all ties back to the World Economic Forum. And the founder of the World Economic Forum, his name is Klaus Schwab, Dr. Klaus Schwab. He is a mechanical engineer and economist. And the Fourth Industrial Revolution is the next advancement in the way that the world, at least that's what he's trying to predict, which is hard to do, how it's going to do things in the future. Who else has 3D printers and who else is interested in additive manufacturing? The government. And in here there is a section about autonomous warfare. Autonomous warfare, including the deployment of military robots and artificial intelligence powered by automated weaponry, holds out on the prospect of robo-war, which will play a transformative role in future conflicts. The seabed and space are also likely to become increasingly militarized as more and more actors, state and commercial, gain the ability to send up satellites and mobile unmanned underwater vehicles capable of disrupting fiber optic cables and satellite traffic. It mentions unmanned underwater vehicles. One of the contracts that HYLN has with the Office of Naval Research are on large unmanned surface vessels. And this is why the government is interested in artificial intelligence. They want to automate, which is scary, automating things that can carry out military tasks. And there's also a section about renewable energy. This enables power to be generated locally, revolutionizing supply chains and enhancing the capacity to print parts on demand, even in remote locations. So let's listen to this additive manufacturing video clip. It's a little bit longer, but they're also interested in it.
Press this button, print, part comes out after 30 minutes or an hour. Great. But the education is really the key because, again, certain printers are appropriate for going on ships and submarines and certain ones aren't. And then, again, getting into the certification part. students need to understand, and officers that go out to the fleet need to understand if this part is meeting, especially with submarine sub-safe requirements, and what the appropriate use of it is, ma'am. And that's where the education piece ties in.
Yeah, so
they want to be able to take 3D printers with them on vessels. That's part of it, and print the parts that they need when they need it. Just press a button, print, 30 minutes later, you get your part. It's quite a ways from there, but they're currently looking at this stuff.
So Matthew, you've been listening to all this. Any questions you have for anybody here?
Yeah, I think I'll start with Jesse, actually, but I think it applies to probably all of us. As we go to scale, right, and maybe I'm posturing a little bit ahead of the question, right, because we have to go to scale, right, trying to double our demand signal, right.
It's not a question as if they're going to scale. That's already answered. That's a yes. It's now, when are they going to go to scale?
That's the mission we're on, or our capacity need AM to contribute to like a 20% increase in metal forming capacity for submarines for both new construction and sustainment, right? As we move towards that, from what you've seen at Pratt Whitney, and I think from what we see with the expeditionary mission as well, and Zach, what you're seeing as you go and reach out to everybody, including the folks who work in our Center of Excellence and other things, what are our biggest hurdles ahead?
Yeah, great question. Let me think about that one. There are, I want to speak very highly of additive, right? Additive.
No, the gentleman all the way over on the right, he is from a defense contractor.
Is a very great technology. It's a great opportunity for us to use for many different reasons in different applications. And like I said, I mean, we've used additive everywhere from rapid prototyping, development, to tooling and fixturing out on the shop floor. And those are the kind of the easy ones, and those are what got us into the entry level side of it. The scalability I talk about, it's really, I think, and you talk about education, I do think those things are really key, and it's about that deconvoluting of the process, because some of the biggest barriers that we face is that we go and we can create parts very quickly, but they do sit on the shelf waiting for that final approval and that understanding and that confidence that we need to give to that end customer, that end use customer. And so, I think we've done a really good job of understanding what AM can do, what AM, what some of the nuances are, what some of the issues, or not issues, but the boundaries of the different AM modalities are. It's really now gaining that confidence and applying them in the right application and making sure we're all talking the same language when we talk about certification, qualification, and application, right?
If I go back to Mr. Boyer, just from an industry perspective, I mean, I like your question and understand from the business case, right? I mean, when you think about, our budgets and the monies that we have and we're entrusted with to use to, provide a fighting force for America and to be able to defend the homeland and protect national security, we need to think in business terms as well, right? I mean, the Marine Corps budget is not a small budget by any stretch of the imagination, and we appreciate the Congress's support for that, right? And we also have to think about business cases as well, so that we can, when we turn to our industry partners, we understand some of the opportunities or challenges you might face as well. So, what from a DoD perspective would be something that would make things easier for you, or you would be appreciative that we could do for you? Understand there's legal and there's different requirements that are in place for reasons, but is there anything that you can think of that we could help with?
So what I will say is that, in general, we've seen a lot more collaboration, right? And I think that's one of the keys is to continue that collaboration, to truly understand what those needs are, and then to see how we can fit different either funding vehicles or research vehicles, S&T, and that type of stuff. And again, I think we need to move that kind of past the early TRL, MRLs. We're into the industrializing. And so I think that's some of the things that would help us out the most, is really to continue this collaboration.
I said the word industrializing like as in terms of the fourth industrial revolution, maybe.
Not that I don't want to see S&T funded, right? And that's me personally, right? But we do need to make that transition to the industrialization side. And really, what is it going to take for us to truly industrialize this AM supply chain, and whether it's internal, external.
So they're looking to industrialize additive manufacturing. One of the key, and that's one of the key drivers for the fourth industrial revolution, is additive manufacturing and 3D printing, and Calibrium provides one of those types of keys for it. And that's probably why Mr. Healy uses the term unlock occasionally, not so much now, but in the past. It all traces back to this World Economic Forum. That's it for this video. Thanks for watching.